Hello guys, today's problem is minimum deletions to make string balanced. You are given a string made up of only two characters, lowercase a and lowercase b. You are allowed to delete any number of characters from the string. The goal is to make the string balanced. A string is considered balanced if there is no situation where a character b appears before a character a. In other words, all the a characters must come before any b characters in the string. Your task is to find and return the minimum number of deletions required to make the given string balanced. Example 1. Input. The string is arbabarb. Output. 2 deletions are required. Explanation. In this string, there are several places where the character b appears before the character a, which violates the balance condition. One way to fix this is by deleting the characters at index positions 2 and 6. After removing these characters, the string becomes arb, which is balanced because all the a characters appear before any b characters. Another valid way is to delete the characters at index positions 3 and 6. After these deletions, the string becomes arb, which is also balanced for the same reason. In both cases, exactly 2 deletions are enough, and it is not possible to do it with fewer deletions. Therefore, the answer is 2. Example 2. Input. The string is bbarb. Output. 2 deletions are required. Explanation. In this string, the first 2 characters are b, and they appear before several a characters, which makes the string unbalanced. To make the string balanced, those leading b characters must be removed. Deleting the first 2 characters results in the string arab, where all the a characters come before any b characters. This requires exactly 2 deletions, and no solution with fewer deletions exists. Hence, the answer is 2. Let's understand the idea behind this solution. A string is considered balanced if all the letter a characters come before any b characters. That means we should never have a b on the left side and an a on the right side. This solution works by imagining a split point in the string. Everything on the left side of the split should ideally be only a, and everything on the right side should ideally be only b. Now let's see how the code implements this idea. First, we initialize a variable called minute deletions with the length of the string. This is the worst-case scenario where we delete all characters except 1. Next, we count how many a characters exist in the entire string and store that in remaining a. This represents how many a characters are still to the right of our current position. We also maintain a variable called seen b, which tracks how many b characters we have already seen while scanning from left to right. Now we start scanning the string character by character. At each position, we imagine placing a split at that point. If the current character is a, we reduce remaining a because one a is moving from the right side to the left side. At this split point, all b characters seen so far on the left side must be deleted. All a characters remaining on the right side must be deleted. So the total deletions required at this point is seen b plus remaining a. We update minute deletions with the minimum value found so far. If the current character is b, we increase seen b because this b is now part of the left side. By checking all possible split points, we guarantee that we find the minimum number of deletions needed to make the string balanced. Finally, we return minute deletions. Approach summary. The approach used here is greedy scanning from left to right. Try every possible split point. Count invalid b characters on the left. Count invalid a characters on the right. Choose the split that requires the fewest deletions. This avoids brute force and works in a single pass after counting. This approach is efficient, clean, and interview-friendly, and it clearly shows how thinking in terms of splitting the string simplifies the problem. Okay, let's hit run. Yeah, all the test cases are passed successfully. And now we can confidently submit the solution. Boom, the all test cases are passed. That's it for this problem. The key takeaway here is learning how to convert a deletion problem into a counting and partitioning problem. By imagining a split point and calculating violations on each side, we arrive at a very clean and efficient solution. If this explanation helped you, make sure to like the video, subscribe to the channel, and share it with someone preparing for coding interviews. I've give the solution link in the description, check it out. See you in the next problem.